Hi everyone, my name is Hernández-Vaquero and welcome to this tutorial where we'll dive into the world of Word2Vec. Today, we'll explore how to train a custom Word2Vec model and use it to build a job recommendation system. We'll break it all down step by step, covering everything from tokenizing text to calculating embeddings and making smart recommendations based on semantic similarity. If you're new to Word2Vec or looking for a hands-on example of how to use it in Python, this tutorial is for you. Don't worry if some concepts seem advanced. I'll guide you through every detail so that by the end of this video, you'll have a solid understanding of how Word2Vec works and how you can apply it in your own projects. You can find the full code we'll use in this tutorial on my GitHub, linked on the screen. Feel free to visit, download the code, and follow along or adapt it to your needs. Let's get started and unlock the power of Word2Vec. Step 1. Install the required libraries. Before starting, ensure that you have the necessary libraries installed. We'll use Pandas for handling the dataset, Gensim for training the Word2Vec model, and Scikit-Learn for computing cosine similarity. To install this, run the following command. Step 2. Import libraries. Start by importing the required libraries. Here's what each library does. Pandas manages and processes the dataset. Word2Vec trains and works with word embeddings. Cosine similarity computes similarity between vectors, and NumPy performs numerical operations. Step 3. Load and inspect the dataset. Load your dataset containing job titles. This dataset should include at least one column, which is job title. This will display the first 5 rows of the dataset, giving you an overview of the data structure. Step 4. Tokenize job titles. Tokenize the job titles by splitting them into individual words. This step prepares the data for training the Word2Vec model. Each job title is now represented as a list of words, which serves as input for Word2Vec. Step 5. Train the Word2Vec model. Train a Word2Vec model using the tokenized job titles. Specify parameters such as the embedding size, window size, and minimum word frequency. Here's what the parameters mean. Vector size stands for the dimensionality of the word vectors. Window stands for the maximum distance between the current and predicted word. Min count ignores words that appear less than this number. Workers means the number of threads for parallel processing. Step 6. Calculate average embeddings for job titles. Define a function to compute the average embedding for each job title by averaging the embeddings of its words. Apply this function to the tokenized job titles to calculate their embeddings. Now, each job title has a corresponding vector representation based on its words. Step 7. Inspect the embeddings. Check the embeddings alongside the job titles to verify the results. This will display the job titles and their calculated embedding vectors. Step 8. Compute embeddings for search queries. Define a function to calculate the embedding for a search query by averaging the embeddings of its words. This function processes the search query the same way as the job titles, ensuring consistency. Step 9. Get job recommendations. Define a function to find similar job titles based on the search query embedding. This involves calculating cosine similarity between the search embedding and the job title embeddings. Step 10. Prepare data for recommendations. Extract the job title embeddings and titles for use in the recommendation function. 11. Get and display recommendations. Finally, use the getRecommendations function to generate and display the top recommendations based on a search query. This will output a data frame with the recommended job titles, their locations, connections, and similarity scores. Thank you so much for watching this tutorial on Word2Vec. I hope it helped you understand how to use this powerful tool for building recommendation systems and exploring word embeddings. If you enjoyed this tutorial or found it helpful, please consider giving it a like, sharing your thoughts in the comments, and subscribing to the channel for more content like this. In our next video, we'll take it a step further by diving into global vectors for word representation. We'll explore how it works, compare it to Word2Vec, and show you how to use it for your own projects. You won't want to miss it. Thanks again for the support, and I look forward to seeing you in the next tutorial. Let's keep learning and growing together. See you next time.